Hello, today we are going to look into pointers. I'm going to declare integers x equal to 10. I'm going to declare a pointer which is going to point to the integer x. That's what first I'm going to declare. Int star ip. So this is how I declare a pointer which points to integer. Int star ip, I declare a pointer which points to an integer data type. I could have declared it in another way. I could have written int star iq. This is another way to declare. As you could notice, it does not matter where the space is. It could have been int space star ip or int star iq. So this is how you declare a pointer. Now we have told that this pointer, it's a pointer which is going to point to an integer data type. Now what if I wanted a pointer which is going to point to a character data type? I could have had char here. Or if I wanted a float data type, I could have had a float here. So if I had written float star iq, it means iq is a pointer which points to a float data type. Okay, this much is clear. Now, so I have just now declared a pointer which is going to point to an integer, right? Integer. But which integer? Which integer variable, right? So that I haven't assigned that. It's just like I have declared. It's like declaring a variable int z, right? That z does not have a value as of now. So right now ip also does not have a value. Now if I want to assign a value to this ip, what kind of value can I assign? What kind of values can I assign to an integer data type? I can assign integers. What kind of values can I assign to a int star ip? I can assign the address of an integer. That's what ip can take. So now first I want to assign the address of the x variable x. How do I do that? I'm going to write int ip is equal to ampersand x. ip is assigned the address of variable x. That's good. ip is now assigned the address of variable x. Ampersand gives me the address of a variable, right? The next operation we would want is, given an address, how can I use it to get the value in that address? So ip contains an address, right? And I'm going to put z equal to star ip. The value in the address pointed by ip is now assigned to z. So clear? ip is an address to a location. Now what is the value in that location? To get the value in that location, you use star ip. Now we have assigned z equal to star ip, means the value in that location is pointed to by ip is now going to be put in z. Let's print off a few things and see how. So first I'm going to print x equal to %d. What is the value of x? We would expect it to be 10, right? Now printf, we want to, let's say I want to printf the address of x. If I want to printf the address of x, How do I do it? I'm going to use %d. Where is the address of X stored now? It's there in IP. So I can just write IP here. So IP is the address of X. I'm going to have one printf in there. So the line. Yes. So it's saying it's right. So it's basically a warning which says that see IP is an integer. Sorry, you have asked %d is basically for an integer, but now IP is not an integer but an address. So it's saying there might be some problems. And address of integer is a non-negative number. So on the other hand, %d is to print an integer which can be positive or negative. Now to print an non-negative integer, I have used %u. One small correction I did. I'm telling it's a non-negative number, but on the other hand, it is an IP address. So you can forget the warning. Right, now I have printed this. And what is it? Right, so X is equal to 10 and the address of X is this huge. So this is the location in our memory where this value 10 is stored. Okay, this is the location in our memory where this value 10 is stored. So let me just see, let's print the value at that location and see value at location where IP points equal to. So what should the value be? The value should be 10, right? Because we know that IP points to X, right? So I just filed it. Okay, value at location where IP points is 10. That's exactly how we want it. Let's print Z and see what should Z be. Z is equal to, you could see Z has been assigned the value of been assigned 10 because it's assigned the value at the location IP points to, which is 10. Right? X equal to 10, address is thing, Z is also 10. Good. Now I'm going to do the following. I'm going to change the value X to 11. Now let me see. We have now changed the value of X. We're going to print after changing. So I've changed the value of X and now we're going to see all the values again. What has happened to each of them? There's some semicolon element. File. Right. Right. So initially X was 10, address of X is this huge number. Value at location where IP points, basically where this address points to, is 10. That is equal to 10. Right. So this Z has been assigned the value where IP points to. So therefore Z has become. Now I have changed the value of X to 11. So X becomes 11. Address of X remains the same because the address of X did not change. Now what is the value at location where IP points to? It has become 7. Right? Because why? Because IP was pointing to the address, the location where X is. Since the value at x has changed, star IP also has changed. Finally, what about z? The value at z remains the same because we have copied the value at x in the beginning. That's the value 10 has been copied to z. Z remains 10. The value at z won't change. Now I'm going to do another thing. What is star IP? Star IP is the so it's basically the value at location x, right? Now I'm going to change the value at location x to be 20. And I'm going to see this thing again. So I've changed the value of star IP to be 20. Okay, so it's exactly equivalent to x equal to 20. So after you look at the last paragraph, change the value of x, x has become 20, address of x remains the same, star IP is also 20, and z remains 10. The next thing is we could have also initialized the value of IP when we declared IP itself. For example, we could have written int star IP is equal to ampersand, and I could have just removed. Let me just comment it out, and it should work exactly like it worked earlier. It's same. There is no difference. This is exactly like we had declared and assigned here integer variable, right? I have assigned x is equal to 10 while I declared, but here I just declared, I didn't assign it. That's exactly same. So a pointer is basically just like another variable, but it's data type is a pointer. Data int star is basically another data type. In many places you could have replaced x with star IP, as you have just now noticed. In place of x equal to 11, you could have written star IP is equal to 11. And now I show you some other things which you could have done. For example, you could have done, so right now x is equal to 20, right? Because star IP is 20. So I could have also done the following. Star IP is equal to star IP plus 1. So what is it? Let me just add plus 10. And now let me print the value of x and see. X is right now 20, and I have added 10 more to 20. So x should now print as print 30, and we just do that. Yeah, x is now 30. So I could have done this. I could have also, I mean, obviously I could have used some, could have used minus, I could have used, let me use multiplication, and become 200, 20 into 10, 200. In place of x plus plus, I could have written star IP, but remember to put a bracket. Star is a singleton operator, right? Here it operates on one variable, and plus plus is also a singleton operator. It operates on one variable. When you have two singleton operators, put proper bracketing so that things are correctly identified. So this is basically saying go to the location IP points to, that is star IP, and increment that value, the value there. That's what it's saying. So should be 21, yeah, and we have 21. So we do not put bracket, it's basically it's like this, whose meaning we will soon see. This has a different meaning which we will soon see. This is different from star IP.